Welcome, everybody. My name is Coach Reese. I'm with 16626, the Radical Raiders, but I'm also secretary of the Northwest Florida section of the American Institute of Aeronautics and Astronautics, or AIAA, which is them. And so when this whole competition started, and we found out about the drones, paper airplanes. I thought it was a great tie-in with the AIAA. Our section has been pretty involved with FIRST. Myself as a coach, one of our other officers is a coach at FLL, and we've done a lot of donations between both of them. So I started looking into, what could AIAA do as far as the drones and FTC. And lo and behold, we found out that Ken Blackburn here is local to our section, member of AIAA. And so great, we've got this great resource, world champion or world record holder multiple times. And so asked him if he could give you a little bit of introduction to paper airplanes, little tips and tricks kind of things. And so here we are. So thank you all for coming, and thank you, Ken. And I guess I'll hand it over to you and start sharing the presentation when you're ready.
Okay, yeah, that's great. Hi, everyone. Good to be here. Yeah, I've been an aeronautical engineer for almost 4 decades, so that makes me really old. But I used to work at Boeing, and now I work for the Air Force Research Lab at Eglin, and I've set the Guinness record, as Reese just said, 4 times. So I've written some paper airplane books, but what I want to do is I looked over your competition, and it looked like obviously there's a drone. It's not the only thing that your robot has to do, but it seems like a great way to add points to your score, and it is it should be fun. All right, should be interesting. So happy to help out, and I can pass along what I know about what might work and what you should maybe focus on, kind of lessons learned type things. Can you bring up the slides? Great. Okay, I am Ken Blackburn, and go ahead to the next slide if you could. And I cut and paste some of the paper airplane rules and just highlighted some of the
right. So it's got to be a paper airplane with wings and a body. And the link at the very bottom of this page has examples from the organization. You may have already seen it. Great examples of what is a legal paper airplane and what isn't, if you have questions on that. Right, you've got to have it the right color. It wasn't clear to me how much of it had to be the right color, like if you use just like but I think it said that predominantly had to be that color. So but maybe you have to look at the rules. But I have found that colored paper sometimes is more flexible than white paper, but I'm sure colored paper will work just fine. Just make sure it's at 20 pound or 75 grams per square meter limit. 20-pound paper is normal copier paper, so as long as it's that weight or lighter, it should be fine. When you put your team number on it, don't press down too hard or bend the paper. That will change the way it flies. In your case, you want it to fly straight and predictably. So if you bend the wing, it may not fly predictably. And then the last highlighted area in red there is the no other material. So no tape, no paper clips. One of the easiest ways to make a plane fly very straight and predictably is to put a lot of weight on the nose, right? That's how darts work. Moving the balance point or the weight forward on any airplane, whether it's a dart or an F-18, will make the airplane more stable, make it fly. So in our case, our best way of adding weight on the nose is using folds of paper on the nose. to add weight. Next slide. So this is where I wanted to put in information about ideas about the launcher. I put a picture of the kind of the arena at the bottom and added the point areas there in zone 1, 2, and 3. You're launching, if I understand it correctly, from behind the truss system. And if you look at it just directly from the side, I made a little picture there on the bottom left of the slide showing zones 1, 2, 3, the launch area, behind the 2-foot high truss system, and then the 1-foot high fence at the very end. So basically, you've got to go about 6 feet or so over a 1-foot wall. So I saw some videos online that showed some examples of how people had approached this. The most popular seemed to be a slot with a rubber band just to make a kind of a rail launcher. And that is fine. So that will work. That's the simplest way to do that. I will say from my experience, rubber bands tend to change their springiness over time. Like if you stretch it, let's say that you stretch it and you pull back, like 10 grams. Over time, that if you hold it like nail it to the wall, over time, tension will go from 10 to 9 to 8 to 7 grams. So over time, that tension is going to reduce, which means that your launch distance will change over time. If you can use a mechanical spring, it should be very consistent, right? Rubber bands are easy though, so if you're in a pinch, rubber bands are fine, they'll work. But just beware that over time, the tension changes. So you might test it and it goes exactly 8 feet. You go to the competition, it's taking longer than you expected. It might only go 6 feet, right? So just beware of that. I saw one approach. It was kind of like a pitching machine where it's a couple of wheels. One of the wheels has a motor that presses the fuselage. It's kind of hard to describe, but it's like a pitching machine. That works. But my concern there is that if you're using the battery from your robot, as the battery depletes, the speed of that motor decreases, and the steady state speed is proportional to the voltage, roughly, unless you have a regulator to keep the voltage constant at the motor. So just beware of that, is that if you're using a motor to help launch it, that may change as the battery depletes. One concept that I did not see, but would also be viable, is to use like a spinning arm, kind of like a catapult. This is kind of a catapult, right? You could use a rotating arm on your robot to launch. Have just like a little cup section on the end, and the arm springs up and hits the stop, and off goes the paper airplane at whatever speed and you've launched it. I think that would be a viable way as well, and that it kind of automatically stows, back, because I know you have a height and a size limit before you enter the competition. As far as adjusting the distance that it flies, you can adjust either the angle that you launch the paper airplane or the speed that you launch the paper airplane. And of course, there are also the adjustments to the paper airplane itself, so it glides, pitches down or pitches up. But the easiest ways to adjust the distance are probably the angle and the speed. Ballistic path, the maximum distance is going to be in the ballpark of a 45-degree angle. It's kind of intuitive. If you just think about throwing a baseball or something, the maximum distance you can get it is kind of about a 45-degree angle. And more than anything, no matter what approach you use, very important you practice. You're going to learn a lot just by going out there and experimenting, and you'll also learn how consistent it is, what things will make it work better, and what things will cause it to fail by practicing. So That's probably the number one thing of anything I have on here is just do it. Just go out and practice. Next slide. I have a few slides here on just the basics of paper airplanes and getting them to fly well. First and foremost, I thought this was kind of a trivial slide when I first made it. And I was talking to an instructor at a school, and actually it was a museum. He's the curator of the museum, and I was explaining how the wings and the work just like airplane wings, and it's stable just like, for the same reasons as an airplane. And he goes, "You mean this thing flies just like an airplane?" I go, "Absolutely." To me, I take it any paper airplane is an airplane. It's just small, right? But it's the exact same physics. Next slide. The four forces of flight. Heard of those? To me, it's kind of intuitive. There is really your thrust is really just your initial launcher providing the initial acceleration, and once it's in flight, of course, there's no propulsion, and a paper airplane will coast just like a bicycle coasts when you stop pedaling it, or a snow skier coasts, once they're going downhill. And gliders, as this is really a paper glider, can propel itself just by using gravity to provide that forward thrust by descend at an angle. Lift we'll talk about next. Weight is pretty obvious. One sheet of paper, remember, 20-pound paper for 2,000 sheets. That makes every paper airplane made with a standard size sheet of paper 1/100th of a pound, or about 4.5 grams. And then drag is just inevitable by going through the air. Your drag on your paper airplane going through the air will probably be on the order of about 1 to 2 grams of drag. But I'm not sure that your knowing that is going to help you to win the contest. Next slide. Okay, so lift, Bernoulli's principle. I think a lot of us, or if you've looked into the science of flight, you'll see Bernoulli's principle. Air going faster has less pressure or suction compared to air going slower. So by tilting a wing, by either curving the wing or tilting the wing, will help to accelerate the air over the top. And if you have ever seen like the Blue Angels, I know that they had homecoming last weekend at Pensacola Beach. If you've ever seen an airplane fly upside down, it's obvious it's not just the shape of the wing, it's the angle of the wing as well. And you kind of know that intuitively if you've ever put your hand out a car window, not that I advocate that, but if you tilt your hand up and down, you can feel the lift of the air on your hand by tilting it. And that's exactly how airplanes like the F-18s or Air Force F-35s create lift, is by angling the nose or the wing more up or down. And if you go to the next slide, what you see is that any airplane, whether it's a paper airplane or a C-17 like I have in the image there, behaves like a seesaw, where if you press up and down on the tail by deflecting it into the airstream, it makes the whole airplane rotate like a seesaw would. It will rotate about its balance point, or center of gravity as we call it, so that you can control how much lift an airplane generates by deflecting the tails, because you want to rotate it just like you would a seesaw. Now, in our case, we can adjust how far the airplane will fly by bending the elevator up more, so that will pivot the whole paper airplane so it's more nose high. It will basically ram into the air a little bit more, so the bottom of the wing kind of rams into the air a little bit and accelerates the air over the wing, creates lift, and it will fly further. So that's where you have to be careful. Remember, I said not to press down hard when you write your team number on your wing. It's because if you bend the wing and it deflects the airstream at the nose or the tail, it it can create more lift or create less lift and make your airplane either fly further or shorter than you expected. So try not to bend your wings. Next slide. Just like I said, an airplane or a paper airplane behaves like a seesaw in pitch to create lift. You can also make the airplane skid left or right by using the rudder, just like you would a boat. It's the same principle as using the elevator for lift, right? You can make the airplane turn by making it skid more to the right or more to the left. So if you, and this is where this is important for the competition, if you have an airplane and they're all going to be, no matter how much you try to make it symmetric and even and uncreased and perfect, it will be a little asymmetric. One wing will be a little heavier, a little angled, a little rougher. You will get asymmetries and the plane will want to turn a little bit. So you can correct that by bending the rudder in the direction you want it to go. And again, you will never know exactly how much to bend it or how that works unless you practice. So I would encourage you to practice using the rudder to make it fly straight. You've got a pretty wide area to hit. So if it turns just a little bit, it shouldn't affect your ability to hit zones 1, 2, or 3. But if it turns a lot, I mean, I've been in lots of paper airplane competitions where someone throws a paper airplane and it circles back around and lands at their feet. So, you know, if there are big enough asymmetries in your airplane, it'll be a real problem. So test fly these airplanes, use the rudder to make them fly straight. Next slide. Dihedral, right? Or the angle of the wing relative to the body. For this competition, as long as the wings are pretty level, it should work great. Generally, I prefer for the wings to be up, like the airplane at the top, which is like an AT-6. You know, and if you look at most birds when they fly, most of the time they have the wings angled up. Most airplanes, if you look at them carefully, airliners, most small airplanes, the wings angle up just a little bit, you know, around 2 to 5 degrees. There are a few contradictions or differences of that. At the bottom is an AV-8B Harrier. I actually worked on that for a little bit. Its wings angled down, but it's for very different reasons than for the way it flies. It was for when it hovers in a crosswind that it would stay level. But generally you want your wings to be level or a little bit up. Next slide down. Balance. I think I mentioned this up at the front about you know, a paper clip on the nose of a paper airplane is not a bad idea because it makes it more nose heavy and will make it fly smoother. It'll make it more stable. You know, light airplanes like in the top left, like that Cessna 172, the heaviest part of the whole airplane is the engine, and it's stuck out in the front to help add weight to make it balance properly. The F-15 in the bottom left, the engines are actually back at the tail. So if you look, they slid the wings all the way back to where they're essentially touching the tail. Because what matters is where the weight is relative to the wing. In your case, without being able to add paper clips or ballast or any kind of artificial weight to the nose, you can add folds of paper. So on the top right, the square paper airplane, you can see that there are lots of folds that were added so it had enough weight on the front to make it stable and to fly smoothly. Dart shapes, like the bottom right, are generally stable enough. If you want to make it a little more stable, you can take that pointy front and just take an inch or two of it and just fold it back over the top of the airplane. And that adds, it will essentially become like a little bit of ballast to help it fly a little bit smoother. So folds of paper on the nose will help to make it fly smoother. I recommend you try it and experiment to make sure that you're getting a paper airplane that flies predictably and smooth. Next slide. So wing shape. people gravitate toward pointed paper airplanes. They do look cool. I mean, I think they look cooler. They look faster. They don't really reduce drag until you get above about 500 miles an hour. So unless your throw's a lot faster than my throw, it really doesn't make a difference on drag, but it does look better. One thing it really does do is it can potentially make it stable, right? Like I said, stability is where the weight is relative to where the wing is. And a triangular wing, like a dart, most of the wing area is in the back, right? So that helps to make the plane a little more stable, help it to fly a little straighter. My biggest problem with square paper airplanes is they don't like to fly straight. They like to turn. They create lots of lift, which is good for you're setting a record for time in the air. I want something that creates a lot of lift. Really hard to make those airplanes fly perfectly straight. The darts, more stable, they fly straighter. So generally, I would recommend some type of a pointed airplane or something with swept wings, just because they're more stable. And the next slide, last one. All right. Just a recap of some of the adjustments that really help on your airplane. The Y shape or dihedral helped it remain a little more stable. I put up elevator. Instead of up elevator, I'm going to say adjust the elevator as needed to keep it from nosediving or from pitching up, right? Watch the way your airplane flies. Generally, if it's nose heavy, you'll end up bending the elevator up a little bit to make it fly smoothly, but watch the way your airplane flies. My guess is for this competition, you will need no elevator or very, very, very little. And then weight on the nose, greater stability. Since you can't add weight, that will have to come from folds of paper. That's what I had for the presentation. Are there any questions, thoughts? Any idea on your approach for your launcher or how you're going to do your paper airplane?
Does it make a difference if you grab the plane in the or from the back, like throwing wise?
Good question. I generally hold my airplanes near the front. The reason being is that you can imagine if you hold it near the back, and basically if the wind gets under it, it will try to flip over, right? Where you're holding it becomes like a pivot point, kind of like the center of gravity. So if you're holding it behind the center of lift, it will tend to want to flip over. So I like to hold it near the front. Generally, if you're launching with like a rubber band, it's easier to wrap it around the back. And you do run a little bit of a risk there that if it bends the back of the paper airplane when it pushes, that could be like deflecting the rudder, or it may permanently angle it as it leaves, and it may cause it to turn. Again, you'll just have to experiment. I have made launchers where I cut a little paper notch in the bottom of the airplane near the front, and then I put my either rubber band or whatever I'm using to launch it in that notch. But again, experiment. So I prefer to hold near the front. If your launcher requires you to push against the back, that's okay, as long as it's constrained in a slot or in something that's holding the airplane.
Graham?
Go ahead.
Graham's got his hand raised.
I wanted to ask if you've ever created a paper airplane that has similar movements to F-14 Tomcat's wings.
Oh yeah, the swing wings. So I have not made one that actively will rotate. I think out of just a pure paper airplane that would be, I'm not saying it's impossible, but it may not be easy. The F-14, if for those who don't know, well, first of all, you have to watch the original Top Gun, right? That was the original Top Gun airplane. And what you'll see is that for landing on the carrier and for taking off from the carrier, the wings are almost straight out because the wings get more lift and have less drag at low speeds by being straight out to the sides. And then when you go supersonic, the wings sweep back and you get the lower supersonic drag. So it was kind of the best of all worlds, being able to fly slowly to land on the carrier, being able to sweep back so it could fly about 2.5 times the speed of sound for flying as an interceptor, as it was designed to do for the fleet. There are paper replicas of F-14s and other airplanes with swing wings like that, like the B-1 bomber. There are some Russian airplanes as well that have that swing wing feature. Short answer is no, I haven't done that, but I'm familiar with what it is, and it's a pretty good lesson on why you would want wings to be straight and why you would want them to be swept back.
And
Anyone else?
I see Eden has a question in chat, which I think I'll take this question because it's about rules, but it says, do scissors count as a material to create the paper airplane? Which I assume you mean, can you use scissors to help with the construction? Because obviously putting scissors into your paper airplane won't work. But yes, you can actually cut the paper. The things you need to be careful of is that you can't cut a piece off and then somehow reattach it. But like Ken mentioned, with the having a notch towards the front, you can actually cut a notch into the paper airplane, and you would just take that little bit of paper that gets cut off and throw it away. You can't use it for anything else. So if you need any more clarification, just speak up.
Yeah, that sounds good.
Anyone else?
So if I could ask, where are you at on your design for your whole robot? Have you started yet?
So our league, AeroCoast, we've had our first competition already.
Okay.
So we had one, was it 2 weeks ago? Something like that. And so we actually did launch our drone once. We had some technical issues the other times.
Are you using a like a rubber band in a like a slot rail system to launch it?
Yeah. Allie, you want to explain, since instead of me explaining?
Sure. So basically, we're using a piece of surgical tubing as like a rubber band, and we pull it back, and then the string is on like a servo that acts as the trigger. And so the servo just moves a little pin, which releases the tension. So it's like a slingshot.
Okay. No, that sounds good. And as I was saying, any kind of elastic launcher. I've working at the Air Force Research Lab. We were experimenting with different drones and how to launch basically heavy, fast drones. And so we would need launchers to do that. And we made some of our own launchers. Some of them were using surgical tubing and bungee cords. And the last one that I worked on, it weighed 20 pounds, and we had to get it up to 100 miles an hour in order for it to fly. So that was a bungee, 3 sets of heavy bungees that were about 50 feet long that we had to stretch to 400 pounds to get that to launch. But one thing that we over time, we experimented a lot with that launcher, and we ended up having to mathematically, use analysis and to try and figure out the best ways to to get that to work. And during our test, we kind of noticed that the bungees, once you pull it, like we said, we'd pull it to 400 pounds. After about 30 seconds, it was down to about 370 pounds. And then another minute later, it was down to 340 pounds. And that's where my lesson learned was that if you use an elastic launcher, you have to be careful on time, because the tension will change over time, and that will change the distance that it flies.
Yeah, we had a similar issue because we left our launcher loaded overnight on the way to the competition. Yeah, so we had to replace it.
Yeah, it's you don't often hear about how bungees or surgical tubing will kind of deteriorate over time, but it does. I remember years ago, I actually went bungee jumping, and the people who ran the business said they had like a limit of I think 10 jumps for a set of cords, because over time they stretched and would start to deteriorate. So, but as long as you're aware of it, I think you can control it. But you have to be aware that it will change over time, and you have to plan accordingly.
Graham, you got your hand raised again?
Yeah, I wanted to ask, how do the wheels on a plane, how are the wheels on a plane able to stop the high speed, like when the aircraft lands?
Oh, well, they've got good brakes, but that's weight is critical on airplanes. So they make the tires as light as possible, and they make the brakes as light as possible. The wheels on the space shuttle, if you're aware of that, I know I'm a little before your time since it hasn't flown in a little while, but that landed on a runway at Kennedy Space Center, and those tires were only good for one landing, and they'd have to switch them out because the rubber was as thin as they could get away with, and just wear and tear from one landing was enough to where they'd have to throw away the tire. So you'll notice a number of museums have space shuttle tires for that reason. The brakes, airplanes have to go through when they're going through their circulation. The biggest challenge for a set of brakes is what they call a rejected takeoff, where the airplane accelerates all the way up to takeoff speed, and then if there's a problem with the engine at that moment, you have to try and stop, but you only have half the runway left to stop in, right? If you're landing like a normal landing, you've got the entire runway to stop on. If you do this rejected takeoff, you may have less than half the runway to stop on. And so that's where the brakes can get red hot, because just like the car brakes, the brakes on your car, they typically use disc brakes where there's calipers that squeeze it's kind of like on the current bicycles, except there's so much friction, there's so much speed that by the time the airplane stops, the brakes are glowing red hot. So it's but they try to design those wheels and brakes and right to the limit because they're heavy. Landing gear tends to be about 10% of the weight of the airplane, so 5 to 10%. So you need to make those brakes as absolutely as light as possible.
Okay, thanks.
Sure. Any other questions? Well, let me ask you this: when's your next competition?
Our next competition is in like a week or two, I believe.
It's the
18th.
weekend before Thanksgiving, like the week, like for the break.
I believe
November
that
18th.
it's on this Saturday.
Yeah, so he did open this up to everybody in Florida, so there might be a couple different dates. But yeah, our next one is November 18th for the Panhandle.
Well, excellent.
So coming up quick.
It always does come up quick.
Yeah.
Any other thoughts
Anyone?
or?
I was gonna say something else on slowing airplanes is especially on commercial airplanes, you might end up with thrust reversers. So and there's a couple different variations on that. If you ever sit, looking out the window over the back of the wing, you might actually see part of the engine kind of slide back and expose like this kind of honeycomb area, which is basically the thrust reverser. It's allowing the air to go towards the front instead of shooting out the back. There were some older ones that had like clamshells that opened up, and yeah, it's another way of slowing airplanes down. So try and save the brakes a little bit.
Absolutely. One other thought, I didn't have it on the slides, but you probably know this. Really, really sharp creases help. So, for your airplane, depending on the design you're using, probably especially since you can't use tape, there's a good chance that the folds will open up a little bit as it goes to the air. The more they open up, the more drag you have and the shorter the distance that it'll go. So, one of the variables that will affect how far your airplane goes is how much drag it's got. So making sure that you have really, really sharp creases to keep those folds together will not only help it to go a little further, which, I mean, you can always overcome that with like more, bungee tension and, a greater launch force, but it makes it less predictable. Because if you don't know how much it's going to open, it'll change how far it goes. So by having the really sharp creases and a really, keeping the airplane as compact as possible will help to make it more predictable on how far it goes. And it looked to me like that's a big part in being able to hit that zone 1 or 2 is to make the flight profile very predictable.
By the way, our one launch that we did in our last competition, we did get the first zone.
Wow.
So
when looking at that, I didn't think that was going to be very easy. So congratulations on that.
In your opinion, with the planes, how do you think it is possible to get like to a 100% consistency with the plane of hitting it every time, or do you think the planes are just too unpredictable to do that?
I think there's a really good chance that it can be, fairly consistent. It's a matter of, how much variation. And I think that comes with experimenting and right. There are some things I can tell you that will probably help, and there's some things that you just really won't know unless you go out and launch, 20 or 30 times. So honestly, I really don't know. I think they can be fairly consistent. If you have a design where the folds can stay in place, there's like one design I use, it's called in my books I call it the Eagle, but it's got a locked fold. Basically it's got a fold that kind of folds back over and holds all the others tightly together. so you don't need tape to keep it closed. I've also heard it you referred to as the Nakamura lock. On some of the other designs, it's basically just a lock fold in origami. But that will make it more consistent. Your launcher, like I said, you probably have a good 10 or 20% variation in just your bungee force, depending on how long it's been sitting. So again, like a mechanical spring could probably reduce that variance a little bit. You'll always have some friction in paper. One of the reasons I don't always recommend that paper airplanes, I mean, I advocate them for science projects because they're, well, of course I'm biased. I think they're cool, but the paper is just much less consistent than like balsa wood or styrofoam or other materials that are more rigid. So paper varies with humidity. Right, just a rainy day can be enough to make it, curl or bend or become very flexible. So, it can be more consistent. It can be very consistent, but quite frankly, it's hard to control how humid it is inside of the arena where you're flying. That's one nice thing about winter. It's almost always dry, and the cold air is dry air, and so. On a cold day, the air is almost always really dry. But there are things you can do to make it more consistent, but it'll never be there'll always be some variance. I'm not sure I really answered your question, but I guess my emphasis is practice and doing focusing on things that you can control will help.
All right, thank you.
Sure.
So question in chat was, my sister wants to know if planes run on gas, batteries, fossil fuel, etc.
Wow. So it all depends on the plane, right? So of course, like light airplanes, typically gasoline, kind of like high octane, 100 octane for a lot of small airplanes. Some of them can fly on automotive gasoline. Most jet engines run on essentially kerosene or diesel fuel. There's a whole set of like air taxis that they're developing. They look like giant multi-rotors or quad rotors. They're actually the Air Force test site for that is Duke Field, right here between Crestview and Fort Walton Beach. The first one arrived just like a week or two ago, and they're going to get some more in. And so we should actually start seeing them maybe in the area, particularly if you're driving on Highway 85. Those are all electric. There were also a project where they took a giant airplane with solar cells and actually flew around the world on just solar power and electricity. So, and of course, gliders don't have any fuel at all. So there's a lot of, but most airplanes, if you see them flying overhead, they're going to be flying on light airplanes, typically gasoline, big airplanes like diesel and kerosene.
And if a plane has a reverse thruster on the nose, how it will work when the plane is landing at such high speeds. I guess I'll take this one since I mentioned the thrust reversers, but I don't know if I've ever seen a thrust reverser on the nose, but hypothetically, it shouldn't make a difference because the reverse thrust would just be a force countering the forward speed. So it would just slow it down the same way as if the thrust reverser is on the tail, or if you have a pair of them on the wings. Although if the nose is still up when you reverse the thrust, that might make things interesting.
Yeah. Yeah, when they started adding jet engines after World War II or at the end of World War II, it became obvious that you know, on a jet engine, the exhaust is really hot and really fast. So they had to move the engines to the back of the airplane or to the wings, and so it makes it hard to have a thrust reverser on the nose, just because the jet engines, it's hard for them to exist. You're right. You don't want that hot exhaust blowing over the airplane.
You know, if you're seeing like a jet, you know, fighter jet like a F-16 or F-35 or something, you know, you might see the intakes for the jet fairly close to the nose, but the jet, you know, the engine is actually all the way at the back, and there's just a lot of duct work that gets the air to them. But they don't have thrust reversers. They might have a speed brake, which is just a panel that raises up to cause as much drag as you can. How hot can jet engines get? Geez, I don't know.
So they push jet engines right up to, well, the hottest part of the jet engine is what they call the turbine, which is right behind where the combustion happens. And they push the temperature right up to where the steel will melt or get soft. So they're looking for ways of actively cooling the steel, and even using ceramics. So it can be a couple thousand degrees in the hot section of a jet engine.
Yeah. Yeah, there's a lot of materials work that goes into turbines and cooling, active cooling. Lots of air chambers going through turbine blades, and you know, they're trying to 3D print turbines so that they can you know, print them with the cooling chambers going through them. Lots of interesting stuff going on with that, because they do get so hot.
And it's to their advantage. The hotter they get, the more efficient they can be. And there's a lot of financial incentives, and for the military, just performance, to get as much performance and efficiency out of the engines as possible. So they are constantly really pushing materials, just like you said, because it makes the engines higher performance and it makes them burn less fuel. So, so yeah, they push them as hot as they can get them.
Right. Well, I guess that would probably be it. So oh, I got Graham raising his hand. Go ahead, Graham.
Is a fighter jet's hook for getting caught on the arrest line for that's on the aircraft carrier?
Can you repeat that?
Is a fighter jet's hook for getting caught on the arrest line on the aircraft carrier?
Yeah, so Navy aircraft are made to, you know, generally fly all the time from an aircraft carrier, and they have to, right? Even though, you know, we talk about the F-14, its wings being out and they fly slowly, that's still like 150 miles an hour that they're coming in, and they have to stop in just a few hundred feet. So in order to stop them, they put a big hook on the back to catch these lines that are across the back of the aircraft carrier, and they catch the wire, and it'll give them a very abrupt stop. Now, Air Force fighters also obviously fly very fast, and they have to worry about if their brakes go out, and they have found that there's a benefit to having a small hook. They don't have to stop as rapidly as a Navy fighter, but a lot of Air Force fighters have small hooks on them as well. And you will find that even like here at Eglin Air Force Base, there are cables stretched across the runway, so that if a fighter has a problem, like its brakes go out or it's coming in too fast, they can use that small hook to help them stop. So Navy fighters they can't really operate from a aircraft carrier unless it's like a vertical takeoff and landing, like the F-35B or an AV-8B Harrier. But the Air Force planes typically don't use their hooks, but sometimes they could use them in an emergency if they had to.
And I
But
actually
if you
did see a F-15 take a hook. So
really,
yeah, at Pax River.
oh wow. And if you've ever flown on an airliner from out of Fort Walton Beach, Eglin runway, a lot of the times you'll feel that those airliners, you know, go bump, 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 bump as they go across those cables.
Last call for questions. All right. Well, thank you, Ken. I guess we'll call it a night.
Yeah, thank you for arranging this. Thank you for putting up. It seems like it's probably my computer or my internet or something that was creating the audio breakup earlier. So I appreciate you bearing with me on getting that fixed.
No problem. And I'll have to get together with you sometime after I get a couple of your books and get them signed. And yeah, so for those of you in AeroCoast, AIAA is going to do a couple extra competitions at the championship using your drones. I think we're going to have 4 different competitions, and I'll try and have rules out to everybody at the next the competition meet number 2 in November 18th. So you can prepare, and there'll be cash prizes, plus we're gonna give away some of Ken's books autographed.
Excellent. Thanks, everyone.
Thank you. Good
Thank
night,
you,
everybody.
sir.